All right, 1.6, we've done sine, cosine. Now we're on to tangent and cotangent first. So a couple of things to be aware. In sine, cosine, one full period was 2 pi. Now our period is pi when we're looking at tangents. We're going to focus on tangent first. Now, if you remember when we look at our tangent around the circle, there are times when tangent is undefined because we cannot divide by 0. And that happens at these vertical asymptotes. At all those vertical asymptotes, tangent is undefined. So our period, typically for tangent, this point right here is at the origin. So a lot of times that's kind of like your turning point where it's kind of going up, a little swivel. It's still going up, but it kind of has a little curve to it, kind of like a cubic, but it's not cubic. Our domain then is always eliminating all these values that x cannot be. So this n is basically saying, because a period is pi, every time that we know where our vertical asymptotes are in tangent without any numbers, it's always going to be at pi over 2. We can add pi each and every time or subtract pi each and every time, and it will always show us a vertical asymptote. The range can be all real numbers because it's going on forever up and it's going down forever. So all real numbers for our range. And again, those vertical asymptotes always are in an increment of pi because their period is pi. And our symmetry, we have a symmetry for this, just like how we had symmetry for sine and cosine, would be at the origin. Now, how is that different from cotangent? Well, every place that the tangent has a vertical asymptote, if you look pi over 2, that's where our cotangent is touching the x-axis because they are reciprocals. So our period here is still pi, except now when we're talking about our vertical asymptotes, cotangent is every pi units because our vertical asymptotes are at pi, 2 pi, negative 2 pi, whereas our tangent asymptote is every half a pi. So that's the difference between the two. That's the biggest difference. Now, when we're talking about our period, again, it's important to know the period of cotangent and tangent is pi. So when we are looking at our equation right up here, and this b value, this changes our period. It's still going to change our period except for tangent and cotangent. When we're looking at our period, it's going to be, our period will be deciding at pi over b. For sine and cosine, it's 2 pi because one full period in sine and cosine is 2 pi. Here, it's pi, so that's a major, not a major, the difference between the two. Our amplitude is still going to be the absolute value of our a value. So first, when I'm looking at this tangent, kind of looking at this number is my b value. So I'm looking at my period. Because my b value here is 1/2, I would do pi over 2 divided by 1/2. Well, pi over 2 divided by 1/2 is the same thing as pi times 2, times by the reciprocal. So now this is going to change our period to 2 pi. Now, if you look at this tangent, typically we had a vertical asymptote at pi over 2, but this is going to affect, this period is going to affect each of these increments. So we're still going to start at the origin. Our amplitude is still going to be going on forever, going down forever. So we're really just focusing on these vertical asymptotes. Now, I do want you to still try to do 2 full rotations. So in this case, when we're talking about tangent, 2 tangent marks. That would be 2 periods. So when I'm looking at this, 1 full period is 2 pi. So if I multiply this by 2, because that's where that 2 comes in right here, that b value, 1 asymptote will be at pi now. And then my other asymptote will be at negative pi. Again, because of that b at 1/2, it changes. This is not drawn to scale, but I believe you guys can see what I'm talking about. And then I have the 2 pi. Sorry, I meant 3 pi, because again, I have to add 2 pi for that. But now, when I'm looking at this, it starts at the origin, because that's in the middle of negative pi and pi. So in the middle of pi and 3 pi, we do have our 2 pi, because again, this is where it should cross the origin. Halfway in between your vertical asymptotes should be where it crosses the origin. And there's no horizontal or vertical shifts. It does not have any other changing. So in this case now, when I'm drawing this, we're going to go, even again, this is not drawn to scale, up on the right, down on the left, up on the right, down on the left. Again, this would be 2 periods because we have 2 pi right here. So here's 1, 2 pi, 1, 2 pi. So that was 2 periods. So this second one, first I'm going to state what's all going on here. So this is going to have a reflect. That negative will reflect across the x-axis because that's our a value. My amplitude is going to be the absolute value of -3, which will be at 3. And now the b value here is 2. So that's going to affect my period again. And tangent, it's always pi divided by your b value. So now my b value is going to shrink. Whoopsie, sorry, I'm off the chart. By 1/2. So this, my period was 2. So I had to double it. Here, my period is 1/2 pi. So now I'm going to have to divide by 2. Again, if we bring it back to this, typically our asymptote is at pi over 2. But if I make it smaller, right here and right here, that's where my new vertical asymptote is going to be. Now, if I divide by 2 or multiply by 1/2, now I know my 2 new asymptotes for this graph are going to be at pi over 4 and negative pi over 4. So right here, vertical asymptote. Again, 1 period is pi over 2. Right here, pi over 2 is 1 period. So my next vertical asymptote, if I take pi over 4 plus pi over 2, which in this case is just like 1/4 plus 1/2, would be 3 pi over 4. In between this is my pi over 2. Why is that important? Because that's where it should cross the x-axis, just like at the origin crosses the x-axis. Now, looking at these other transformations that we have. Because of the amplitude and because it goes on forever, this one is not as clear on this graph. However, this reflects over the x-axis. Typically, from our origin, we move up to the right and down to the left. But now, because of this reflection, we're going to move down to the right and up to the left, down to the right and up to the left. So there is 2 periods because, again, each period is pi over 2. But now I want you to pause the video and state any transformations you see for cotangent. Now this is cotangent, so the graph's going to look different, but first I just want you to say the transformations. Now our period is going to be 3 pi because our b value is 1/3. Our amplitude or a value is 2. Again, amplitude is not really, I just keep saying amplitude, but in cotangent and tangent, it's not really the same because it's going on forever. But this 3 pi. Now if we go back to what cotangent looks like, cotangent has your vertical asymptote start at the origin. So personally, I think this is a little bit easier if I'm looking for 2 periods because of the fact that I start at 0. So since I know that my 2 periods are 3 pi, that means 1, I'm going to write to the side because I wrote a thick line, will be at 0. The next, then, because its period is 3 pi, will be at 3 pi. So that would be 1 vertical asymptote. That's going to be 1 period. And now, if I add 3 pi to that again, this will be at 6 pi. And once you know your vertical asymptotes, these numbers right in the middle are right in between that period. So in this case, if from 0 to 3, if I'm looking for what's in the half of 3, it's 1/2, or we can say 3 pi over 2. So this is 3 pi over 2. Again, in between 3 and 6 would be 4/2. So that would be 9 pi over 2. So this is where we cross the x-axis because we did not have any shifts up or down, left or right. So right now, again, cotangent, if we look back at what our graph looks like, it's the reciprocal. So this one naturally goes up on the left and down on the right. Where we just graphed the tangent when it was a negative, it flipped it. But again, cotangent is reciprocal. So in this case, this is going to go up on the left when it is not reflected and down on the right. Up on the left and down on the right. So that is what that graph would look like. And now we have cosecant and secant. If something you notice about cosecant and secant is because of that reciprocal of sine and cosine, it's basically, once we know what sine is, again, sine, remember, starts at the origin, goes up and down and back to the center. Cosine starts up and goes down then to the center. Our cosecant is going to be looking like a parabola, but it's not. Looking like a parabola on each of our relative max in our relative mins. Notice wherever the sine goes through my x-axis, there's a vertical asymptote there, because remember, this would be like 0 over a number. Well, when I take the reciprocal of that, we can't divide by 0, so that's why we have vertical asymptotes. And just like tangent and cotangent, that's saying that every time a pi unit, because we have these vertical asymptotes, or where those vertical asymptotes typically are. But our period is still going to be at 2 pi. And if we're looking for this, this is always going to be divided by b. And our amplitude, in this case, I say amplitude because I'm talking about my sine and cosine, is still going to be looking at our absolute value of a, because this is important for where our relative max and our relative min are located. So this first one, first I'm going to translate this into what it would look like if it was sine. So 1 sine x plus pi over 4. That's a 4. I want you to pause the video and state any transformations that we have with this 2 and this pi over 4. So our amplitude is at 2, and now we're moving left pi over 4 because it's opposite left. So I'm first going to just draw a sketch of sine without these transformations with a pencil. You might just want to sit and relax or just watch what we have without these reflections. So this is what our normal sine looks like. So just be aware we're going to be drawing 3 different graphs in this. The reason I'm doing this is because this left pi over 4 is not in our increment that we're using. So because of this left pi over 4, I'm going to have to add new tick marks because all of these spots have to move left pi over 4. So in this orange, I'm going to draw the sine with an amplitude of 2 left pi over 4. So this is just the transformation from sine to this sine amplitude of 2 and our left pi over 4. Notice how left pi over 4 is still in between, is still pi over 2. It's just shifted left a little bit. So once I have my sine, any place it goes through my x-axis, I should have a vertical asymptote. So when I'm doing my cosecant now, whenever I'm going through that x-axis is a vertical asymptote. So again, the amplitude here is not really amplitude when I'm talking about secant or cosecant or secant. It's more about where the relative min in. So now that I have this relative max here, this is the same point I'm going to start with my cosecant. So hopefully you can see the different colors. And it's going to kind of look like a parabola up until you get to those vertical asymptotes. And here, this right here is 1 period of cosecant. And then I have another one because cosecant is also naturally a period of 2 pi because we have a relative max and a relative min. So this is what that graph would be like. I want to say that yes, this one's a little bit more difficult because of that little tricky guy. So right now I want you to pause the video and try to do question 5 by yourself, best to your ability. So this is my cosecant with that period of pi. So here's 1 period. Remember, cosecant starts up. 1 period, 2 period. So when I found these spots, 1 period's pi, divide that by 2, divide that by 2. That's what's going to be our increments for our local max, local min. So now when I'm doing my my secant, wherever it goes through the x-axis, we should have our vertical asymptote. So all these spots, we should have our vertical asymptote. So right here, we have our local max. So it's going to be something like this. Even though I don't have it, I'm still going to draw that U. Here's my local min, local max. Again, never crossing the asymptotes. And look at that, bing, bada, boom, you're that much smarter. We will be doing what we called as damp graphs in class, which is a little bit more tricky. But that's all we have for today. Have a great and wonderful day.